Hello loyal subscribers, I'm going to once again do something different to my usual upload. This time I'm walking you through how I make my 3D printed ships, from planning, modeling, all the way to printing them out and hoping it doesn't end up as plastic waste. As promised in my last video, I will be printing the USS Alabama. It is a good looking ship, not too big, and overall should be easy to model. There won't be any gameplay footages in this video, so I'm gonna make up for it with good graphics, and hopefully you can also learn a thing or two about 3D printing. Before we start working on the model, we have to perform some checks. There are 3 requirements that must be met. Number 1. The main features of the ship must be able to be reproduced, such as main guns, secondaries, rangefinders, the mast, hull details, lifeboats, and aviation. Anything else will depend on its printability. If it's too small, it will be discarded. Number 2. It must be printable with any stock FDM printers with minimal setup, and individual parts can go straight to assembly without refinement. But of course, not every part on a ship can fulfill these 2 requirements. This is where the 3rd criteria comes into play. Every single part must complete the ship at any means necessary. Basically, if a particular part contributes to the overall look of the ship, but not possible to be 3D printed due to technical limitations, which I will explain later, I will modify the geometry, even if it requires me to heavily distort or simplify the shape. It's not that I don't want to make accurate details, but it simply won't be practical given the constraints of 3D printing. This brings us to scale, and why I ended up with this particular number. To put it simply, the industry standard 700 scale is too small for important parts like gun barrels to be printed reliably, even when you increase the size, and we know they're kinda important on warships. Meanwhile, the 350 scale is too big. It would take exponentially more time to model all the new details that are now becomes printable. This specific scale, however, is good enough to print the smallest of gun barrel, good enough to print the bigger AA guns, and from what I've seen it doesn't create much issues. Once I'm confident that the ship can be printed, the next step is separating the ship into segments. This is to simplify printing, and most importantly allows the use of different colored filaments. There are 4 kinds of segments: the lower hull, the upper hull, the decks, and the superstructures. Each of them builds on top of each other with the armaments coming last. The main gun barbettes will be part of the deck, and small miscellaneous objects will be attached to the nearest segment it touches. Once I visualized how the ship goes together, we can start modeling. First, I take the 3D model from this website, mainly for convenience. This website provides the 3D format of the ship that could easily be imported to my 3D program. The main purpose of the model is to be a reference to the size, positions, and proportions of all the various parts of the ship. Next, I create a simple flat plane and start building the geometry following the reference model. This may look like geometry tracing, but not really, because I will be using different topology and further modify the model to make it printable. You have seen how some parts get simplified and distorted, but what about the other way around? Take this bow segment as an example. You can clearly see what is called the triangles. If I were to take the model as it were and put it in the printing program, those triangles will also be visible. This is called faceting, and we don't want that. To solve this, we need more triangles to get smaller faces and therefore smoother result. We do this by subdividing the polygon, adding more edges, adjusting their position in relation to the model, and keep adding them until those triangles are no longer visible on the preview. This is a core principle of my modeling process, maintaining the balance between reducing or increasing fidelity in order to get the best result possible for a bone stock 3D printer. Now, we can tackle some design challenges when making a 3D printable model. Let's start with a simple example on the Alabama, and look at the signature indentation on the midsection. It has what is called an overhang, which is something that extends out with no support. Think of gun barrel, hanging platforms, and German battleship mains. You see, this is an absolute no-no for 3D printers, and that's because of how 3D printers work. They print the model by layering melted plastic on top of each other, and because these plastic were still melting when the print head goes the other way, gravity does the rest, and you get these ugly looking prints. There are 3 solutions for this. First is to add removable support, which is self-explanatory, but this adds post-processing, print time, and another point of failure. The other solution, which is my preferred one for most cases, is to add a slope. This prevents the layer from extending too far and allows it to support itself, but at the cost of model accuracy. The last one is to split the whole thing, so the overhang becomes the bottom of the part. This is how I deal with the Fuso pagoda mast and what allows it to be infinitely stackable. And this is why the Fuso superstructure is a lot more complicated to make than something like the Yamato superstructure. Totally not foreshadowing my future plans. So what do we learn? Well, we learned that 3D printers are more like 2.5D printers with how they actually work, and you must be able to figure out the best way to deal with their limitations. Another useful 3D printing solution is bridging. It joins two parts together without support underneath. This is possible because bridging is not affected by directional changes that compromises the melting plastic, because it's still being suspended by the nozzle, which allows you to print floating objects with near flawless result. And it has a specific use case on an unlikely part, which is the armament mechanism. You see, the main guns of the model must be able to rotate and also raise the barrels. This is because some ships have their gun barrels resting on different elevation, and this is how I use bridging for both. I start by making the turret body, then I cut a cylindrical hole inside the turret to interface with the barbette. The roof of this hole will be closed off by bridging the perimeter. Pretty simple thing. This also applies to other objects that needs to be joined together. The challenging part is making the barrels movable. It cannot be part of the turret body because it has to move up and down. It needs support structure, yet it also has to be easy to print. So how do I deal with this? First I model all the barrel as a separate assembly and put the axis of rotation inside the turret. Then, I make a cavity inside the turret that will house the barrel assembly with just enough room for slight movement. Now comes the simple but genius part. From the barrel axis of rotation comes a shaft that directly connects to the turret body, turning both entity as one object. This shaft allows the barrel assembly to move up and down with a small amount of twisting. The only thing to do now is to add support underneath the rest of the barrel outside of the turret. All of this is possible thanks to bridging, which allows the axle to be printed inside the turret body without using supports. And remember, we are working on an object that is no bigger than your thumb. Alright then. That's 2 design challenges sorted out. Now I will do the actual modeling and give you some of the highlights. We continue where we left off, which is building the upper hull, adding more edges, and sculpting them to be as smooth as possible. Once the outer hull is complete, I gave it a small lip along the top part of the hull, and then I make a flat base inside of it. This is to create a stable base for the deck segment later. Then I work on the lower hull, and because the lower hull will be printed upside down, I can take advantage of bridging to make the propeller shaft, as they were supported by these braces. I also joined the rudder to the lower hull. All of this is to simplify assembly. The only thing that didn't get modeled are the propellers. Next I create holes for small round magnets, so both hulls can be joined easily. And finally, I added the barbettes for the main guns on the upper hull. Now we work on the main deck. It is made from the shape of the upper hull that we made earlier. Then I shape it to go around the gun barbettes. Once that's done, I add a small distance between both objects to compensate for printing tolerance. This is applied to any part that interfaces with each other. The Alabama also has this little superstructure piece between the front guns, so I also model the main deck around it. Fun fact, most of my modeling are made possible using the Mark I eyeball, including how I measure distances between objects. I just couldn't be bothered to scrutinize everything down to the exact numbers. That being said, I'm using this rudimentary measurement tool for determining minimum part thickness. I will cover this shortly. The next part to be tackled are the superstructures. Starting from level 1, this will be the easiest to model, but it immediately gets harder on level 2 and above, with many floating platforms that needs to be accounted for, including the decks, all while simultaneously figuring out how to reduce the number of printed parts. So after imagining things, I ended up with this arrangement. 4 main superstructure pieces, with most of the overhanging part attached to them, while the rest becomes its own separate part, with the decks coming later. Now we continue modeling. As usual, parts that needs more definition gets its own treatment by myself. Not too much, just enough to prevent faceting. To deal with overhanging parts that doesn't protrude too far, I gave it a slope to the main superstructure, and it should blend reasonably well with the rest of the model. Now for the red stuff from earlier. This is a 0.8mm thick wall, used to set a minimum thickness for solid railings or similar kind of structure, to give it structural integrity. This kind of object usually needs further refinement to match that reference wall. It isn't hard to do, it's just time consuming. Certain part of the ship may also needs its own special treatment, like this support pillar that were part of the entire superstructure. To make it practical, I split it into 2 pieces, made it thicker, and merged the upper part to the second superstructure. This way it becomes easy to print without straying too far from the original model. Now for the superstructure decks, it's pretty much the same deal as the main deck, and I'm also using the rudimentary measurement tool to get uniform thickness. Some of these decks may require existing superstructure pieces to be modified in order to get the desired look, and by the end of the day I can only hope they will eventually fit together as intended. At this point, I think you get the gist of it, so I'm gonna skip over to the details and finishing touches. Going back to the upper hull, we work on the details of the joints of the hull plating. They add a subtle but noticeable pattern on an otherwise empty hull, and I think it gives character, but as you see, they are not very visible due to the low resolution textures on the imported model, so I have to work with what is visible and make up the rest by cross-referencing the model from inside the game, which does have better texture, but are still difficult to discern in general. I'm sure there are better ways to deal with this, and better way to model them, but I can't be bothered to figure that out, so I'll just throw a lot of rectangles and be happy with it. Now for the details on the decks, I start with spamming a lot of straight horizontal lines that follows the top surface. This is how I replicate the wooden decks on the actual ship. Then I simply build everything else on top of it. Many of the parts are taken from the Ohio model, like the anchor chain assembly, which is just a bunch of overlapping squares. Both of them being American ship means they share an assortment of small parts that I can reuse, saving time and effort, including this new propeller design that are easier to print. After countless hours of adding small rectangles, copying them around the ship, modifying existing model, adding connectors for the superstructure pieces, and many other subtle things, the ship is finally done. Now I can copy everything to the other side, gave it another look to spot any differences, and do one final modeling pass. Once that's done, I grouped all the smaller parts, then I connect them together with sprues. This is to help them stay intact during printing and make them easier to remove. If there are parts that require support structure like the gun barrels, I usually model the support into the part itself to make it more convenient. Finally, I combined all of the objects from every segment into a single model, which can then be exported as a 3D file for printing. Damn, it took quite a while to reach the part where we get to turn zeros and ones into plastic, but these amount of work, along with some compromises, are necessary to get the desired result with the least amount of headache. That's the beauty of making 3D printable model. You get to choose how you make them, you get to share it with others, and most importantly getting it to work on any consumer grade 3D printers. Having said that, my model requires 3 important print settings that needs changing. First is the layer height. I set this to 0.1mm, which I think is reasonable. Next is to change the wall generator to this type that I cannot pronounce, which allows printing using variable line width that can replicate the geometry better than standard settings. And finally, I slow down the print speed to guarantee the best quality possible. The rest of the settings is pretty much personal preference based on needs. Once that's done, we can slice the model, check the slicing result for anything out of the ordinary, before sending it to the printer. And now we wait. While it's printing, I wanna say thank you for all your support that has kept me going for over 9 years. Now closing on my 10th year of making videos about funny warships. I make mistakes all the time. I make videos only when I want to, and I'm still using this ancient text-to-speech voice. But occasionally, I just want to make something different, like this video. It's only now I get the chance to make one with the right kind of subject, so feel free to share your opinions about this format. After a few days of printing, most of them spent on reprinting parts that needs fixing, we finally have all the pieces to complete the ship. Some of them are not perfect. This part has what is called stringing, which happens due to wet filaments or incorrect print settings, but that is okay because they can be addressed using a heat gun. We then cut away all of the sprues that holds the smaller parts together, and because we applied a lot of solutions for this model, putting them together becomes a walk in the park. And here is the final result. This is by far my most polished model. That includes all of the improvements from previous design, and just so happen to be about the same size as the Fuso. You can get it for free in my creators page link below. And with that, it is time to conclude the video. Perhaps it is a bit too long. Perhaps it was too technical, but I hope you enjoyed it, and I would like to apologize if I missed anything. Finally, I would like to appreciate all of my patrons for their support. That enables me to continue making fun, useful, and easily digestible videos. Thank you for watching, and see you on the next one.